finding angles from unit vectors, right? And so what happens if you have a basketball and you throw it up in the air? You throw it up in the air, and you get a velocity. You get some sort of velocity to be in the presence of 7, -4, and 0 meters per second. Okay. My question is, what is the unit vector? Well, we're given a vector, okay, so we got to find its magnitude. So if I take out my calculator, okay, we know the magnitude of the velocity in this case will be the square root of 7 squared plus -4 squared plus 0 squared, okay. So now the magnitude of velocity in this case will be, let's see, 7 squared plus -4 squared, yeah. So the magnitude of velocity is 8.06 meters per second. Okay, so therefore the unit vector, or v hat in this case will be 7, -4, 0, and we divide that by 8.06 meters per second. This is meters per second. So if I take 7 and divide by 8.06, what do I get? I get v hat. I get v hat to be 0.868 in the x direction. If I take -4 and divide by 8.06, I get that to be -0.496, and then we get that to be 0 because anything divided by 0 is just 0. So we have the unit vector. So my question to you is, what if I wanted you to determine theta x, theta y, and theta z? How would you determine the angle in each direction? Well, remember, if remember we said that the unit vector, and could be in a unit vector. So in this case, v hat, unit vector is given by cosine of theta x, cosine of theta y, and cosine of theta z. Okay, cosine of theta z. So therefore, if you want to find the angle in the x direction, we could say cosine of theta x is actually equal to 0.868. Yeah, because the unit vector cosine of theta x has to be equal to that which we just found. Okay, so if that is true, then theta x is going to be cosine inverse of 0.868. Okay, and so if we take cosine inverse of 0.868, we get the angle to be 29.77 degrees in the x direction. Okay, so theta x is equal to 29.77 degrees. Okay, similarly for the y direction, we know cosine of theta y has to be equal to that unit vector, -0.496 in the y direction. Okay, so therefore theta y is going to be cosine inverse of 0.496. Okay, and so if we take cosine inverse of -0.496, then we get the angle to be the theta y to be 119.73 degrees. Okay, and the same thing goes for theta z. We know cosine of theta z has to be equal to 0. So therefore cosine inverse, so therefore theta of z is equal to cosine inverse of 0. And we said cosine inverse of 0 is 90 degrees. Okay, so theta z is actually 90 degrees. So if you want to put the angles together in the x, theta x is 29.77, theta y is 119.73, and theta z is 90 degrees, and these are all in degrees. And so these are how we find angles from unit vectors. And look, this should be true. I should be able to take cosine of these angles and I get back my unit vector. So look, if I take cosine of 90, cosine of 90 is 0. If I take cosine of 11.73, we get that to be negative 0.496. And if we take cosine inverse of 29.77, we get that to be positive 0.868. Okay, and you could see we got back our initial unit vector.